Hello, algebra students. Mr. Lawrence here, and we're going to do a little graphing mini lesson here. Um, in chapter 5, we learned about this thing called slope-intercept form. Remember, y equals mx plus b, and we found out how easy it was to graph. First of all, it's got to be a linear equation, right? And y must be alone. Like this blue equation here, it is definitely linear because the exponents on x and y are both 1, and y is all by itself. So I know the y-intercept is the point 0, 1, right? And I plot that, and then I use rise 1, run 2. Rise 1, run 2, rise 1, run 2, rise 1, run 2, and there we go. Sorry to subject you to my wonderful singing. All right, and so if I draw my line, it's something like that. And I should make it a little bit longer. And I will make it thinner and a different color. I don't want to go red because I want it to stand out. And I'm going to be doing something red in a minute. Okay, so there is the linear equation graphed. Maybe I'll make it blue so that's obvious that which equation it goes to. So there we go. All right, now when I look at this red equation, it looks very similar. It looks linear. It looks like y is alone, except there are these absolute value bars. Well, it's going to behave very much like a linear function, but it's going to be a little bit different. And to show you how it's different, I'm going to come over here. I made this table. I'd love for you to pause the video and see if you can fill out the y column here, and here take the absolute value of all these numbers and write the y column there. All right, so hopefully you can do that on your own. Shouldn't be that big of a deal. I'm going to go over to the blue one. Here comes my solutions. If you haven't tried it yet, please pause. Well, when x is negative 2, x equals y, so therefore y is negative 2. All right, when x is negative 1, y is negative 1. When x is 0, y is 0. When x is 1, y would be 1, and 2, 2. And notice they match perfectly. And that's why we get that nice linear graph. The slope would be 1 over 1, right? The y-intercept would be 0. I know Jarrett Dietrich is thinking, hey, that looks like a direct variation. Yeah, it sure does. And he's right. Okay, coming over here, I have to take the absolute value of negative 2. I have to take the absolute value of negative 1, take the absolute value of 0, take the absolute value of 1, and take the absolute value of 2. So the absolute value of negative 2 is 2. This is 1. This is 0. This is 1. And this is 2. Notice it looks the same for the positive 0, right? When x was positive or 0, we get the same results. But when x was negative, we got the positive results again. What's going to happen is part of this graph is going to be just like the blue graph. It's going to be like this. Okay? But because of the absolute value, it's going to cause it to change direction and go that way. Instead of getting the negative, like negative 1 and negative 2 for the y values, I get positives. And so we get a nice V shape. Now, this point here is called the vertex. If you can find the vertex and then the slope, graphing an absolute value function is a piece of cake. So let's go look at this one here. Hold on a second. Let me get this back to where I want it. All right. Now, in the blue one, our y-intercept was 0, 1. In the red one, we don't know the y-intercept necessarily. We might, but we don't have to. We do know the vertex. We do know the vertex. And the vertex is 0, 1. Now, some of you go, oh, you just take this number. Well, not quite. Not quite. It is true that that number is there. That is true. But this number, I'm going to let you discover in a minute, okay? So I'm going to plot this point, 0, 1. And then this number, this 1/2, is sitting in slopes position, isn't it? And so I can go rise 1, run 2, rise 1, run 2, rise 1, run 2. And I'm going to get a picture that looks like this, right? And let me change the color of that. Properties, I'm going to make him even thinner. I'll make it red. Can I go even thinner? Yeah, there you go. Now you can see that there's a red and a blue there. All right, kind of fooling your eye, making a purple kind of thing. Now, it doesn't just continue forever, because remember, when you take the absolute value, it's going to change direction. So to get the right portion, the part where x is greater than the vertex, stuff on the right side of the vertex, we used 1/2. M was 1/2. What we're going to do now is we're going to use m equals 1 over -2. So we're going to rise 1 and go back 2, rise 1, go back 2, and rise 1, go back 2. And that allows us to get that nice V shape. Okay, let me change that to make it nice and thin. I think I want real thin on it. And I'm going to go red. And it looks something like that. So if I take this blue one away, you can see I get that nice perfect V. Okay? Now the trick is first finding the vertex. Once you find the vertex, you're going to need 2 slopes. The slopes are really easy to use. Usually one moves to the right and one moves to the left. Okay, so let's try this blue one again here. Go ahead, pause the video, see if you can make a graph. Here comes my solution. 0, -4 is the y-intercept right there. My slope is going to be -3 over 1. So I go down 1, 2, 3 and over 1, down 1, 2, 3 and over 1, and up 1, 2, 3 and back 1. All right, so when I do this, I'm going to get a beautiful graph like this. All right, let me, properties, I'll make them a little thinner, put an arrowhead on, and make them blue. Okay, now, you're probably not ready to do the red one on your own yet. I'm going to find the vertex, and the vertex is going to be 0, -4. I know the 0 is a bit of a mystery for you. You just see this -4, and you're going like that, and that's good. I'm going to show you where the 0 comes from in just a minute. Now, the 2 slopes I'm going to use, well, let me plot 0, -4. There we go. I'm going to use -3 over 1, just like I did in the blue one. Down 1, 2, 3, and over 1. Down 1, 2, 3, and over 1. But the other slope I'm going to use, maybe I'll call it slope 1, and then slope 2, is going to be -3. The numerator stays the same, over -1. So I get down 3 and back 1, down 3 and back 1. And so my other ray ends up being this here. Oop, I didn't do either one, did I? Okay. And let's see if I can, if I group those together will allow me to change the properties of it. We will try. All right, make them nice and thin. We'll make them red. And there we go. And there's your graph. Okay. All right, let's try another one here. Now, we're not going to do the blue one. We're just going to come right here. And notice this one's a little bit different. This is going to be where you discover what the vertex actually is. Okay, on all the previous ones, the vertex was 0 and then a number. This one is going to have that 2 in the y coordinate, just like that. But the number we're going to get for the x coordinate, and some of you are thinking, I know it's going to be 1, and you're actually incorrect. It's actually -1. Yeah, it shifts the graph in the other direction. Okay, so I take the opposite sign here. If it's a positive 1, I use a -1. So I'm going to go -1, 2. Let me do this in red. -1, 2, right there. Now my first slope is going to be 1/3. My second slope is going to be 1 over -3. So I go down 1, 1, 2, 3 to the right. Rise -1, run 1, 2, 3. There we go. Then I also do the same 1, 2, 3 in the other direction. 1, 1, 2, 3. All right. And I'm not going to change the colors on this one. It's not going to be that big of a deal because that's going to be the only graph on there. Normally, we don't graph 2 things on the same graph, but I wanted you to see where it was coming from. So I do that, and I do that, and there we go. All right, I got a couple more examples. See, before I do this one, see if you can find the vertex. See if you can find the vertex. And then while you're at it, try to find the 2 slopes. Okay? All right, well, here comes the vertex. It's going to be 4, 1. Yeah, I took the opposite of that sign. It's going to be 4, 1. So 4, 1 is right there. All right, my first slope is going to be -2 over 1. And my second slope is going to be -2 over -1. So I go down 1, 2, over 1, like that, and then I go down 2, over 1, like that. You see, it's pretty simple stuff. And there you go. You get a nice, it's a little bit off because I'm rushing a little bit. I don't want the video to be too long, but there you go. Okay, so why don't you try this one totally on your own? Try everything. Get the vertex, get the two slopes, see if you can get the graph, see if it matches mine. If you're still watching, here comes my solution. Vertex, not sure what that letter was. It's going to be at 2, -4. So I'm going to go to 2, -4 and plot it. First slope, 3 over 1. Second slope is going to be 3 over -1. So I rise 1, 2, 3 and over 1. 1, 2, 3 and over 1. And then up 3, back 1. Up 3, back 1. And there you go. Hopefully you're able to do this by now. It's really not that difficult. And it's actually kind of fun. All right, so let me see here. I got one more for you. Again, try this one on your own. All right, here comes my solution. Vertex is going to be at -5, +3. And the two slopes are -1/2 and positive, oh no, -1 over -2. I don't want to cancel out the two negatives. If I do that, I won't end up with the nice V shape that I'm looking for. Yeah, or the V will be going the wrong way. In this class, all your V's will open either upward or downward. So will your parabolas. When you get up into Algebra 2, you can get some that open left and right. But for the purposes of this class, they'll all be opening up or down. Let's see, my vertex is at -5, 3. 1, 1, 2, 1, 1, 2, and then like this, right? Okay, and I will do that, and then do that, and there you go. All right, that's it for the video. Mr. Laurence signing off. Have a good night, everybody.